Number 13, we have f of x is equal to 3x squared minus 5x minus 1. So here's method 1. Negative b over 2a will equal the negative of negative 5 over 2 times 3. And that equals 5/6, positive. Negative of a negative, remember? It's 5 over 6. And then f of that so that's going to equal, okay, now on this one, this is not very much fun to evaluate, so I would definitely use method 2, completing the square on this one. But let's do this anyway. I hope your professor doesn't require you to not use completing the square, alright, because even though the book doesn't really teach that. Used to be standard practice, though, standard instruction. It was in all the math books too. Alright, so you could use that as a defense for your technique. So this is 3 times 25 over 36 minus 25 over 6 minus 1. And that's 75 over 36. And that's, I suppose I could do some canceling there, but whatever, alright. I was thinking too much about completing the square, and thinking how much easier it is doing it that way. So bear with me here, 6 over 6 minus, and then we got 36 over 36. So that's 75 over 36 minus, that becomes 150 over 36 minus 36 over 36. And that's equal to negative 111 over 36, which reduces to minus 37 over 12. So the vertex is 5/6 minus 37 over 12. Alright. And then finally we can write f of x in standard form. That's put the 3 in front. X minus 5/6 in parentheses, quantity squared, minus 37/12. Okay, so now on to completing the square, method 2, but I need to erase so I can have room here, so hold on a sec while I erase. Okay, on to method 2, completing the square. So we write 3x squared minus 5x minus 1. And group the x squared and x terms. 3x squared minus 5x minus 1. And now factor a 3 out. x squared. Now what do you write here? What you want is 3 times something equals negative 5. 3 times something equals negative 5. Alright, what would that be? Well, you could divide both sides of that by 3 and you'll get the something. That's negative 5/3, right? 3 times negative 5/3 equals negative 5. Okay, so you might not think there's a common factor, but you can force it, so to speak. We've done this before, it's a couple of times. You might not remember us doing that, but you can write negative 5/3. You can always common factor like this. Alright, so again, check your work when you do this. 3 times that, does that in fact equal negative 5? Yes, it does. And then you've got minus 1. Alright. Now what you do is you take half the coefficient of x. I'll do that over here. Half of negative 5/3. Square that. So that's going to be negative 5/6 squared, and that becomes 25/36. Alright, so you're going to add and subtract that number inside the parentheses. So adding 0, you got 3x squared minus 5/3 x plus 25/36 minus 25/36 minus 1. Alright, let me separate this scratch work here. Alright, so that's 3 times x squared minus 5/3 x plus 25/36, and then 3 times minus that becomes minus 3 times 25/36 minus 1. So again, you're multiplying the 3 like you're supposed to times that, and then you can take it out of the parentheses. Alright, so what you'll get is 3 times this. This is a perfect square trinomial, so you could take half of that, that's 5/6, or you could take the square root of that, which again is 5/6. So it's going to be a minus because of that minus there. X minus 5/6 quantity squared. And then this becomes minus, when you do the math here, you're going to get minus 37/12. Which is the same answer, okay? And so we can get the same vertex, read it right off the formula there, all right? So there you go. Okay, number 15. It says, for the following exercises, determine whether there is a minimum or maximum value to each quadratic function. Find the value and the axis of symmetry. Okay, so the value would be the y-coordinate of the vertex. The axis of symmetry would be x equals the x-coordinate of the vertex. All right. So what we need to do is find the vertex, and we need to decide whether the function opens upward or downward. That'll tell us whether we have a max or a min. Alright, so if you have a parabola like this, the vertex is the minimum value. And of course, if you have one like this, opening downward, vertex is the maximum. How do you know whether it opens upward or downward? You look at the leading coefficient. That's the coefficient in front of the x squared. And if it's negative, it opens downward. If it's positive, it opens upward. Okay? Very simple, very simple. So here we have f of x is equal to 2x squared minus 10x plus 4. We need to get the vertex. Now it doesn't tell us how to find that, so I'm going to complete the square on this. Forgive me if you're not into this, but I'm not going to use method 1 on this one. Sorry about that. Since nobody's paying me to do this, I guess it's my choice, right? So that's one of the advantages of doing this for free. See, I get to choose the method. Alright, even if you don't like it, I'm sorry. And maybe if you send me donations, I might use method 1, alright? So, you know, it's open to negotiations, right? Everything's negotiable. 2x squared minus 10x. I'm just kidding. Don't take it seriously. I have a sense of humor. Alright. So factor the 2 out. Like that. And then take half the coefficient of x. You can do this in your head by now, I guess, right? Half of that, don't worry about the sign, half of that is 5/2, square that, that's 25/4. So you add and subtract 25/4 in the parentheses. Alright. X squared minus 5x plus 25/4. Now you multiply the 2 times the minus 25/4, alright, and that the 2 will cancel with the 4. That'll give you minus 25/2. So you can do that part in your head as well. You can change that to 8/2 and then add it to that. Alright, so this becomes 2. You got a minus there, so it's going to be x minus, and then take half of that or square root of that. X minus 5/2, quantity squared, and then minus 17/2. So the vertex is 5/2 and minus 17/2. Now this function, since the leading coefficient is positive, it opens upward. Alright? Opens upward. So what we're going to get with the vertex is a minimum. Alright? So the minimum value, the value refers to the y value, or the y coordinate. The minimum value is negative 17/2. Alright? And the axis of symmetry is x equals the x coordinate there. X equals 5/2. Vertical line. Okay? You could do it with the other method too if you wish. I think you're going to find that it's not as nice as doing it this way, but be my guest. Number 17. We have f of x equals 4x squared plus x minus 1. So 4x squared plus x minus 1 is equal to grouping the x squared and x terms together, and then a minus 1 outside. And then we factor the leading coefficient 4 out of the parentheses. That leaves you with x squared plus, yes, that would be a 1/4 x, because 4 times 1/4 does equal 1. Alright, so, and then a minus 1. So we got 4 x squared plus 1/4 x. Now we take half the coefficient of x and square that and add and subtract it inside the parentheses. So half of that, 1/2 times 1/4 equals 1/8. And then you square 1/8. 1/8 times 1/8 equals 1/64. So we add and subtract 1/64 inside the parentheses. In effect, you're adding 0. There you go. Now we bring out this, bring it out of the parentheses, but first we have to multiply it by 4, okay, before we can do that. So when you do that, 4 times a negative 1/64 will be negative 1/16. So, and then what you have left is 4 times x squared plus 1/4 x plus 1/64. And then minus 1/16 minus 1. Okay, and this, as usual, is a perfect square, trinomial, and it's x plus 1/8. X plus 1/8. Quantities squared. So you could take half of a fourth is an eighth, or you could take square root of 1/64. Again, 1/8. And that's minus 1/16 minus 16/16, which is minus 17/16. Alright, so the vertex is negative 1/8 and negative 17/16. And the leading coefficient is positive, positive 4. So we know it opens upward. Alright? Again, it doesn't matter what that number is there. It matters whether it's positive or negative. And that determines whether it opens upward or downward. So if it's positive, it opens up. Negative, it opens down. So opens upward. And so the value here in the vertex is going to be a minimum value. All right, a minimum value. That would be the y coordinate there. Minimum value is negative 17/16 rather. All right, and the axis of symmetry is x equals negative 1/8. Alright, so the x coordinate there. Don't forget to put x equals negative 1/8 because that describes a vertical line going through negative 1/8. If you just write negative 1/8, you know, that could be just considered a number. So if you write it like this, x equals negative 1/8, that shows that you know that this is a vertical line. Okay, that's how we write vertical lines. That's the way we do it. All right. All right. Number 19. We have f of x is equal to, we have 1/2 x squared plus 3x plus 1. And so 1/2 x squared plus 3x plus 1 is equal to, in parentheses, 1/2 x squared plus 3x, and then close parentheses, plus 1. Factor out the 1/2 leading coefficient. That leaves you with x squared plus, now we're going to have 6x, because 1/2 times 6 is 3, okay? And then plus 1. So we've got 1/2 x squared plus 6x, and then take half the coefficient of x, that's half of 6 is 3. Square that, that gives you 9. 3 squared equals 9. So you're going to add and subtract 9 inside the parentheses. And then you're going to get this negative 9 out, but first you have to multiply it by a half. Half of negative 9 is negative 9/2, so that's what you're going to write out here. And so what we have left is 1/2, parentheses, x squared plus 6x plus 9, and then minus 9 over 2, outside parentheses, plus 1. And now that leaves you with a perfect square trinomial, as we expected, which is x plus 3 in parentheses squared. And a negative 9/2 plus, this is a 2/2. That gives you a negative 7/2. Alright, so the vertex is negative 3, negative 7/2. And it opens upward because the leading coefficient is positive. Opens upward, which means that the vertex is going to be at the bottom of the parabola, which will make this y value here the minimum value. Alright, so the minimum value is negative 7/2. And the axis of symmetry is x equals negative 3. Okay, number 21. It says, for the following exercises, determine the domain and range of the quadratic function. So for 21 we have f of x is equal to, and this is written in standard form, how nice, x minus 3 in parentheses squared plus 2. So we can, well, we want to know the domain and range, alright? Well, this parabola opens upward. The leading coefficient here, well, is a 1, positive 1. So I'm just going to draw just any old parabola. I don't know this. Okay, let's. This is vertex is at 3 and 2, right? So 1, 2, 3, 1, 2, 3, 2, like this. So it looks something like that. Use your imagination. All right. Anyway, the domain. Now, for all of these parabolas, the parabolas keep going. It'll cover all the negative numbers this way. These things keep, even though it looks like it's getting straighter and straighter, it's still going infinitely long distance up, and so it's going to cover the whole x-axis, left and right. All right. So the domain for these parabolas will always be all real numbers, all right? All real numbers, or negative infinity to infinity. It's the range that is kind of restricted. The range starts there at y equals 2, and then it goes up to infinity, positive infinity, all right? So if it goes like this, if the parabola opens downward, the range, the domain again is negative infinity to infinity, and the range will go from this point, whatever that looks like a negative number, down to negative infinity. All right, so that's basically all you need to know to solve this problem. All right, you just get the get the vertex and determine whether it opens upward or downward. And that'll show you what you need to answer the question. So the vertex, like we said, was 3, 2. And it opens upward. I'll just write up. Alright. So the domain, I'll call it D, is equal to negative infinity to infinity. And again, you must use parentheses when you write negative infinity to infinity as an interval. Using interval notation, you never use a bracket indicating you're including that point, because these are not real numbers. Infinity is not a real number, so you cannot include that in the interval. All right, and then the range, R, call it R, is 2, and that includes 2, right? So you're including 2, so you put bracket 2, and then that goes to positive infinity, and that's closed off with a parenthesis. All right, a parenthesis. There you go. Number 23, we have f of x. Oh, they didn't write this in standard form. Rats. So we'll have to do that ourselves. X squared plus 6x plus 4. Okay, so I'll complete the square. X squared plus 6x plus 4 is equal to x squared plus 6x, and then plus 4. And that's x squared plus 6x. Half of that is 3, square that is 9. So plus 9 minus 9 plus 4. And there's only a 1 multiplying everything in the parentheses, so you can just bring that negative 9 out and do it directly like that. X squared plus 6x plus 9, and then minus 9 plus 4. And this is a perfect square trinomial, x plus 3 quantity squared, and then minus a 5, minus 5. Alright, so the vertex is negative 3, negative 5. The leading coefficient in the beginning was positive, so it opens upward. Alright, and so the domain, as always, goes from negative infinity to infinity. And the range, since that negative 5 there is a minimum value, it starts at negative 5 and it goes to positive infinity. There you go. Alright, number 25, we have k of x equals 3x squared minus 6x minus 9. Alright, now, I don't know if they're testing us here or if the author kind of fell asleep here, but we already did this in number 11, exercise 11. Alright, this is the exact same function in exercise 11. So the work has already been done, at least I hope you guys did that one. Alright, so the vertex, we already know, is 1, negative 12. It opens upward. And the domain then is negative infinity to infinity. And the range is negative 12 to infinity, including negative 12. So that was nice and easy.